Today we're going to discuss what are called quadratic functions. And quadratic functions are functions that are going to look different because in the function value they look different. Okay, what do I mean by that? We're going to graph y equals ax squared, and this power is going to affect our graph, and our shapes of our graphs for y equals ax squared are going to be shapes of what we call parabolas or u's. So click pause, make sure you start your notes off with, we'll call these 4-2 notes about quadratic functions, what the basic idea looks like in a quadratic, and what they're called, and then we will start to graph these. So again, hit pause, make sure that you're caught up with your notes, and then we'll start graphing these with the T-chart. Okay, let's talk about the function y equals x squared. So again, I'm going to put in some points for x and y, and let's start off with the points that we did for our parabola. So if I stick in y equals x squared and I put in a 0, I'll get a 0. If I put in a 1, 1 squared is 1. Be careful when you stick in a negative 1. Negative times a negative is a positive 1. So if I graph these 3 points, and I didn't know any better, I might connect these with a V because these are the same exact points in an absolute value. But let's jump and put in a 2 and a negative 2, and I'll show you how it's different. So if I put in a 2, 2 squared would equal a 4. So I'll graph the point 2, 4, and if I plug in the point negative 2, negative 2 squared will also be a 4. So you can see here we're not going to have constant change, but our change is going to be exaggerated as our x gets bigger. And you'll connect these points with what we call a U, or again, we call these parabolas. Not parabolas, but parabolas. So let's look at some of the similarities as far as the vertex goes. This point here is still called the vertex. We will still have what we call a line of symmetry that goes right through the middle. And we'll still go up and over our rise and run to get our second point. But then instead of making a V, we will make a U. So the second graph that I would like to look at is a y equals negative 3x squared. So again, we're going to know it's a parabola, but this number on the outside is going to affect our parabola a little different. So again, let's pick in some points. 0, 1, negative 1 is a good point. If I plug in a 0, I'll get 0 squared times negative 3 is a 0. If I plug in a 1, 1 squared is 1 times a negative 3 is a negative 3. Negative 1 squared is a positive 1 times a negative 3. We'll get a negative 3. So our graph will look different because of this negative 3. How will it look different? We'll have the point 0, 0, 1, negative 3, negative 1, negative 3, and our U will be skinny, and it will point downward. We'll have an axis of symmetry. That axis of symmetry will cut right through the vertices. We'll have the same point on the left as we do on the right. So again, you can use 3 points to do this. When you're graphing your 3 points, make sure that you connect with a U for a parabola, and that's all you have to do. So standard form of a parabola is going to look very similar. If you will write down your standard form, we'll have a y minus k times a times parentheses x minus h quantity squared. So again, some of these important details are the vertex is going to be hk, a is going to be how much we rise and run from the vertex. We're going to connect 3 points, so we'll have a vertex, we'll have our 3 points, but we'll connect those with a smooth curve. Those are called parabolas. And when we graph in vertex form, we'll get practice of just seeing. So if I have a y minus 2 equals 4 times x plus 1, and you'll see this quantity squared, so you know that you have a parabola or a U. To identify the vertex, remember the vertex is the x goes with the x. If it's positive, it's negative. The y coordinate goes with the y, and if it's negative, it'll be positive. So you should see a vertex at negative 1, 2. This is going to go up 4 and over 1, so it's going to be a pretty skinny parabola. And we'll do a couple examples with exact values so you can see what I'm talking about. Again, press pause, make sure you get the standard form, what you're seeing when you get to the standard form. So what I'd like to do now is to go over an example that kind of looks like standard form, and then show you how we can graph these if we know something about standard form. So remember what standard form is. It's y minus k equals a times x minus h quantity squared. This equation that's given to you in problem number 4 isn't quite in standard form, but let me show you where it came from. So standard form, we have to sometimes put equations in standard form so we can read them. So again, if this number is over on the right-hand side, we'll want to move it to the left-hand side so we can identify the vertex. So remember, in a parabola, the vertex is the x is the x, the y is the y. In this case, they're both going to be negative because their values are positive, and when we switch them out, they'll be negative. So let's graph this negative 4, negative 4. Label this as your vertex. I usually will put the vertex and I'll put my line of symmetry in right away. I'm going to use the coefficient in front as how fat or how skinny my parabola is. So I'll go up 2 over 1. That gives me 1 point. X marks the spot on the other side. Connect these points with a smooth curve, and you end up with your first parabola. Press pause. I'm going to try to do one more with you. Again, when the equation starts off, if that 2 is on the other side, we'll actually put it back on the other side so that we can read the vertex. I copied this down wrong, so I'll go back and get this correct now. The first thing you want to do is identify the vertex. So again, the vertex is what? X is x, y is the y point. So I'll go over to 3, positive 2, label your vertex, put your line of symmetry in. Look at how skinny or fat this parabola is. And again, that's that coefficient on the outside. We'll go up 2/1. X marks the spot. Connect in your parabola. So I've got some basic steps of how to do these problems. They're very similar than the absolute value. First, find the vertex. Second, graph the line of symmetry. Move rise over run for 1 point. I'm going to say mark with an X on the other side of your line of symmetry, and then connect with a smooth curve. Make sure that you have parabolas when you have a x squared in your equation. So good luck. Give yourself a chance to do some of the worksheet, and I'll have the answers posted.